Most of the time, vector involves using the origin as part of the question. So when you have a vector starting from the origin, goes to any other point on your graph, we will then call this vector a position vector. So if I'm to just randomly draw a graph like this, x and y, and if this is the origin, then any random point on the graph, if I call it point A, then the line going from O to A will then give us vector OA. So using this concept, for example number 2, if I have a quadrilateral with vertices P, O, P, Q, R, I'm assuming that this is the picture on the XY plane. So here, the y-axis and the x-axis, and I have vector going from O to P. This is the vector OP. And from P to S, this is a vector there. As I add these two vectors together, the resultant vector will then go from O to S. Pretty straightforward. Or if you want to simplify your expressions, you can simply say vector S. For the next one, if I have a different vector going from O to R, go all the way to this point, and then plus PO. Well, we know how to interpret the vector from O to P. If they give us P to O, this is basically the same as having a negative from O to P, because if you're going from P to O this way, having an opposite direction on this vector means we have a vector from O to P. But anyways, I have P to O, and I have drew it on the graph here. Minus from P to S. So which means I can consider this as from S to P. From S to P, here I have a vector going there. So altogether, it seems like I have these three vectors together starting from this point, and it is going to end at that point, even though you have this part being the last piece of your operation. I will still consider these three vectors add up to a line going from S to R. And in this case, I cannot just call it vector R or vector S, because this is not a vector starting from the origin. So if we want to describe any vector, if you